Telecommunication Department. To mark the Shubharamb of this session, I would like our chief guest, our principal sir, and all our faculty members to enlighten the diya. Please, sir. Light being the source of positivity and energy marked the Shubharamb of our event. Give a big round of applause for this. As we know, the human body could not stand without a backbone. Just like that, a college cannot run without a principal. So I would like to call the backbone of our college, our principal sir, Professor Ranjan Kumar Swain sir, on the dais. Please, sir.
Good morning to all. Respected Dr. Devi Prasad Das, the renowned scientist of IMMT. Have you heard the name? Sunicho Nanda, Pile? IMMT na IIMT? Kono? IMMT? Institute of Minerals and Materials Technology. How many are from Bhubaneswar? Where it is? Kalpana Square. Acha, it's okay. So, previously the name was Regional Research Laboratory. Now it has name is changed to Institute of Minerals and Materials Technology. Okay? So these are the basic GK you should have. Okay. Sir is from that place and he is the man who makes all the prototype things by using the basic principle of electronics and knowledge in other area. So it's I can say it's a moment for us to hear him how you can be able to make prototype things from your idea. Certain idea is there, then you have to go for the design. Once you drawing and design, then you have to use the components. In electronics, different components, you have to assemble that, then you get the final product and you see that whether it is functional or not. If it is functional, then it's an achievement. Yes or no? If it's failure, that's a challenge. Then you have to rectify where the fault is. If you want able to rectify that fault, then your confidence level and everything will go up. Yes or no? So, any engineer without practical or without the knowledge how to build a prototype is incomplete in all respects. So I hope Dr. Das will make this session very enjoyable and fruitful, and you will learn a lot. So thanks to again Professor Das for accepting the invitation of the Department of Electronics, the Electronic Society of the PMEC, and came from Bhubaneswar to deliver this talk. Thank you. So hope he will make the entire program of today lively, and it should touch your heart and learning one. Thanks.
Thank you, sir. We have a prominent professionality among us making the environment auspicious. He is none other than Dr. Devi Prasad Das. He is working as the senior principal scientist and head of process engineering and instrumentation department of CSIR IMMT Bhubaneswar. He had done his BSc degree in physics from Utkal University Bhubaneswar 1996. Then he done his MSc degree in electronics from Sambalpur University Bulla in 1998. Then he done his PhD degree in electronics and instrumentation engineering from NIT Rourkela in 2004. In 2003 to 2004, he was the assistant professor and HOD of electronics Silicon Institute of Technology Bhubaneswar. Since May 2008, he has been a scientist in Institute of Mineral and Material Technology, IMT Bhubaneswar, a constitute of Laboratory of Council of Scientists and Industrial Research, India. He had completed guidance of 6 PhDs and he is continuing with 3. He has visited RIMT University, Melbourne, Australia as a postdoctoral research fellow for working in audio signal processing during 2015 and 16. He has done many resources which include active noise control, adaptive signal processing, image processing for mineral industry, microcontroller, machine learning, and much more. He has published many research papers in IEEE. 2 of his technology, ion palette and expert ion palette, are commercially being used in leading steel plants of India. Dr. Das was a recipient of the Odisha Young Scientist Award 2004, CSIR Young Scientist Award 2009, NI Engineering Impact Award runner-up 2014, and much more. He is also selected as the mentor of change of Atal Thinking Lab, Niti Aayog, Government of India. Now I would like to invite Dr. Devi Prasad Das to the dais for his talk. Sir, please.
Thank you, students, for your extensive introduction. I would like to first thank the principal, Swai sir, for whose guidance such type of talks are arranged. And the head of the department, Electronics and Telecommunication, Dinesh sir, he is always after us, people like us, that our students should be exposed to talks of latest relevance and which can generate curiosity and some kind of skills for our students. Those type of talks he used to ask us to deliver. So this is my first talk to the students of Parala Maharaja Engineering College. So though I have been involved in this particular college in different capacity and different committees, but I had no scope before to deliver a talk and share my ideas and interact with you. So this talk is not going to be very, very academic. It will be a kind of motivational talk where which can actually give the engineering students like you in the first year, second year, who can motivate themselves to become a good engineer for the country. So country is lacking lot of engineers. Okay, they may be producing lot of engineers, but the real engineers who can design products for its own use are lacking. Okay, those who are studying in IITs or NITs, they are generally employed abroad, or they change their profession from engineering to management, or sometimes they go to teaching line and again teach subjects. Okay, but the product designers are very, very limited, because of which we are still dependent on foreign countries for almost all our sophisticated things, except our agricultural item. We are dependent on most of the things. For the technology, for the raw materials, for the products, we depend on foreign countries, okay, including China. So, can you please share my slide? So, this talk will be about 45 minutes. Then we can have 15 minutes discussion. So, as you know that there is a slogan called Atmanirbhar Bharat. So, where India wants to be self-reliant, in which we have to reduce our imports, okay, and make things which can be exported, okay, and it will not be used by ourselves. It can also be used by foreign countries, so that we can earn a lot of money. So the topic is something like principle to prototype. The two P's are used just to have a catchy word. There are similar words people use in engineering and the application-oriented research, like idea to industries or lab to land. Okay, like this, like you develop something in the lab, but it has not gone to the land. Okay, suppose you have some idea, it has not gone to the industries. Okay, concept to commercialization. So you have some concept in your mind, but you have not yet made a product which could be commercialized or sold in the market. Similarly, you know a scientific principle or engineering principle or a theory, okay, and you could not make it a product. Okay, so another P is product. So you know a principle that with 4 wheels a vehicle can be made, but you have not made it because you have no zeal of making it. Okay, you have no skill sets, so you have not made it as yet. Okay, so before making a product, we are using the product from outside. So any car companies you say, except Tata, we use most of the imported cars. Okay, but the principles are all taught in engineering colleges. Mechanical engineering, automobile engineering, electronics engineering, all those tops which are being taught, they are all there in our cars. Okay, but we are not able to add any value to it. Whatever is available, we have to just use it. Okay. So this talk is going to motivate you, if you know a particular principle, how you can make a product. But product is something which is finally sellable in the market, which is produced in large quantities. Okay, it is a manufacturing process by which you are repeating, like a chair. So many chairs you have to make. So chair is a product. But if you just make a item where it has got 4 legs and something to sit on, but it not looks like a chair as it is. It's not so beautiful in look, but it is performing the functionality of that. Okay, and it may not be productionized. You cannot repeat it. Suppose tomorrow somebody will say, I need 1,000 of such prototypes. I cannot make because I don't have a production line. Okay, so product is different from prototype. Prototype, I will have some standard definition of Wikipedia. So now you got the concept. So you have some idea or design, like your sir told in one line the whole talk. So you have idea, you have design, you get the components, make something, assemble it, and achieve the functionality. Okay, if you achieve the functionality of one item, that is called a prototype. Okay, then after the prototype is demonstrated to a company or a entrepreneur, he will be able to manufacture it. To manufacture, you also need some other kind of additional inputs required for the product making, like your design, for making the product, so many instruments are required, equipments are required. But we are not even going to the prototype level. So as a student, as a faculty members, our aim is not to make products and make and sell. Okay, our aim is to, since we are educated enough, learning lot of skill sets, lot of theories, appearing exams. Okay, so with those ideas, we should be able to make a prototype. Okay, and which can be demonstrated. Okay, real time it can be shown that, see, this is something I have done by which you will be able to perform this particular functionality. And that should be a novel one. Novel means something innovative, which is not existing elsewhere. Okay, or it may be a very expensive item, you have made it in a low cost solution. Okay, those are called the prototypes. So next please. So you can read it, but from the web, like if you read somewhere, the practice of creating physical prototype is slowly fading. Nowadays, people are not interested in making prototypes. Okay, how many of you are making prototypes? Any projects you have done in your school, college level for contests and demonstrated something? You can raise your hand. You have made something. What is that you made? You can tell in Odia also. Because I think all of us are Odia, right? Okay, you can speak in Odia also.
ଯେତେବେଳେ ସେ ଫ୍ୟାନ୍କୁ ମୁଭ୍ କରାହେବ ତ ସେଥିରୁ ଇଲେକ୍ଟ୍ରିସିଟି ଜେନେରେଟ୍ ହେବ.
Electricity generator, very good. So at least he could able to demonstrate that if you rotate that particular dynamo, mechanical energy you give, you get produce the electrical energy. Okay, so that energy may not be sufficient at that time. Okay, it may not be able to run a fan or something, but he might have shown one LED glowing. Okay, so one product designer will come to you and say that you give me a similar product, okay, improve this so that I should be able to charge my mobile when there is no power anywhere. I am sitting on a bus or a train. Okay, suppose you sit in a train, there is no charger in the train. Okay, there is no power bank, or you are inside a bus going a long distance and suddenly your battery gone. But suppose his product or the prototype you have, so you just sit and rotate, okay, and your mobile is getting charged. Can you not make it? Yes or no? The principle you have to understand. The principle is, if there is a dynamo kind of thing, okay, if you rotate, then some electricity is getting generated. But how much electricity is required for the mobile to get charged? You need to know. So how much that adapter is giving you, the charger is giving you, or the power bank is giving you? It is 5 volt. 5 volt and some current. Okay. So you have to make the dynamo in such a way that it should be able to generate that amount of voltage and current. Okay. But when you rotate the dynamo, it will give a fluctuating voltage, because when you stop, it will be less voltage. When you rotate more, it will be more voltage. But mobile will get damaged if you give a fluctuating voltage to it. Okay. So what is required there? You require a stable voltage. All the time 5 volt. Either you give 5 volt or don't give any voltage. Okay. So what is the circuit you have studied in basic electronics? Which component you require for regulated power supply? Zener diode. Yes or no? So you can make a Zener diode circuit where input, if it is 6 volt or 7 volt or 8 volt, still output will be always 5 volt. Okay, there are also other components, ICs are also available, but you can make a simple Zener diode circuit and you can charge your mobile, and you can, instead of a small motor, you can have a big motor. Okay, so all these principles are taught to you, but we have never made. I have only told you the concepts, but I have also not shown you the prototype. So it is you. Now after going from this talk, you can try. See how much voltage is coming. How you will see the voltage? In which equipment? Multimeter or oscilloscope, you can see. Multimeter will come and go. Okay, but in an oscilloscope, you can see the waveform. Okay, with time, you can see what was past, what is now. So oscilloscopes are required. So you have already used oscilloscope in your lab. So you can use oscilloscope, multimeter, and see how much voltage I am getting. Okay, then you can connect a regulated power supply you can make by using a Zener diode and a resistor. Okay, that circuit is taught to you how to find the value of the resistance and what is the value of the what is the breakdown voltage of the Zener diode. Okay, so connect it and you see what is the input when you rotate and what is the output you see. Okay, input may be changing from 3 volt to 9 volt or something like that, but output will be always 5 volt, or when it is less than 5 volt or 6 volt, it may be 0. Okay, but it will not be more than 5 volt, or it will not be more than 5 volt or less than 5 volt. Then only it tells us regulated power supply. Okay, so because these concepts are fading away, so that is why people like us are coming to educational institute to talk. Okay, so that you will get skilled enough. Like somebody has learned how to draw figures. Okay, when they are in alone or not doing anything, they can do something. Now the bad habit is you watch mobile. Okay, so in mobile also there are a lot of videos on which such type of prototypes are made. So you can reproduce that. Okay, then you can earn your skill sets. Next. So objective of this talk is to encourage towards prototype development. And when you consider about the technology, what is a technology? You might have learned the name called technology. Okay, like you are doing bachelor in technology, no? BTech. Tech is technology. So what is a technology? Okay, so and at what condition, like one AC is a technology, using a particular technology the AC is made. Okay, and the AC becomes a product, but there is a background technology in it. Okay, and when you develop a product, there are different stages of technology readiness. Okay, whether you are now ready for appearing GATE, whether you are ready for appearing JEE main or not. Okay, so like this technology also is having a readiness level. Okay, TRL, that is called TRL. So when you do research or do a project, you cannot say that I have developed something, tomorrow it will be of use. Okay, you have done something in a particular environment, so you have a particular technology readiness level. So that I am going to explain what is a technology readiness level, which one, whatever you do, at what level it is now. Okay, that you can evaluate yourself. So you can see the down arrow, left side is principle and this is a time axis. So in between there is a stage called prototype. You have so many principles. Okay, you can combine them and make a prototype. And after the prototype, it will take again another lot of time to make the product to come to the market. Okay. So to convert easy to understand scientific principle to an innovative product, like I told you now itself during discussion, because of his model, we told how to make a hand-driven battery charger. Okay, you can make one and make it a product, sell it in Amazon. Okay, and a lot of people will buy. Like people are buying our power banks for charging. To carry out product development activity by students and faculties of engineering colleges. So this is the motivation behind delivering this talk. Okay, coming from Bhubaneswar to this place, so that I can at least motivate 10 or 20 students among you who can become tomorrow's product developers for India, so that India will become Atmanirbhar in our product. We will use our own television. We will use our own mobile set. We will use our own AC. We will use our own cars. Okay? But now, present state is not like that. Okay, but the importance of Atmanirbharta is actually understood by our leaders in the center, and now they have stopped lot of imports. For our research, we cannot buy things from China. Okay, it is all stopped. Now you have to buy, you have to make or use indigenous items. The people who have made, startup companies made, you have to use them. Whether it works, doesn't work, doesn't matter. Government money, you have to use indigenous products. So there is now pressure from the top. So when there will be pressure, everybody will work. When there was, we were independent, we were under the British rule. That time there was pressure that we have to be independent first. So people are leaving jobs, leaving studies, and then they are joining the freedom fighter. Now, this is a time we all have to work hard for making India Atmanirbhar. It will not take much time because we all are educated. We are not like the British era. Okay, we are now all educated, lot of money we have. Only thing is we are not concentrating. We are getting flown away by external worlds. So Facebook is made, so we all are the prey to it. We all send WhatsApp. Any message come, we forward. Almost every day we are engaged in those things. Okay, that is why the motivation is now whatever study is given to you, all are very, very vital, and try to implement practical. So the practical, whatever is there in your laboratories, do it sincerely. Okay, and in off time also, because you may be staying in hostel, you can use the laboratory and sufficiently you will learn whatever during this period of stay here. Next. So importance of prototyping. During product design, designers start with a product idea, use various scientific and technical principles. Okay, so for product idea, first is idea is to making a battery charger. Okay, then what are the principles required? So designers start with product idea, use various scientific technical principle, then they can simulate also. So using a CAD tools, computer-aided design tools, there are tools available like your circuit designers. Okay, there are tools available in which you can actually, instead of making something, suppose components are not available with you, you can do simulate. Okay. Now earlier days we have to buy the simulators and load it in our computer and simulate. Nowadays there are a lot of online tools. You search that I want to simulate circuits, online circuit simulator. There itself you can do something. Online PCB designer, it is already there. Online C compiler, it is already there. Earlier we have to download a C compiler, load it in our computer and do it. Okay. So you can even sit in your laboratory computer and do a lot of simulation which are available online. Okay. Then a lot of CAD models you can make and then develop physical prototype to work towards creating the final result. The steps are generally repeated to achieve the final product. As sir told, if you fail, again go back, you see where it is. For example, I make a robot to go in the forward direction. But when I actually make it, it is not going in the straight line. It is turning towards right all the time. Okay, so there is a problem in the alignment. Okay, maybe the wheels are not good. Maybe alignment is not proper. Maybe one side motor is running less than the other side. Okay, so all these I can modify in the next stage. Next, please. So is this visible or not visible? Towards the end, may not be visible. Some people are purposefully sitting at the back, even if seats are available because they don't want to listen. Otherwise, you can sit the TVs there. Okay. So this is very important. This is given by NASA. Okay, because NASA is also a scientific organization doing research. So this is called TRL level. Okay. So TRL 1 to TRL 9, there are levels. So when we do research and say that we have done this research, then the reviewers, our examiners, they ask that what is your TRL level? Okay, means what level you have achieved so far. Or suppose I want to propose that I have to make something like this, you give me this much of money. Then they will say, what is your present TRL level? How much you have done as of now? Okay, TRL 2 or 3 or 4. If I say TRL 4, then he will be able to understand how much I have done. I don't have to tell that I have done this much. Okay, I have to say that I am now in TRL 4. Now if you give this much of fund, I will go to TRL 6. TRL means technology readiness level. So technology, fast technology, I have made it in a bold thing. But this particular image will be available in Google also. You can search it and get it. Okay, this is from NASA site. The first is the lowest one, okay? That is called basic principle observed and reported. Somebody has reported a basic principle in a paper or a research paper or a website, somewhere the basic principle or a book, it is already given, the principle is given, like a Zener diode can make a regulated power supply, it is already reported, okay? Technology concept and application formulated. Using that principle, you are formulating an application, okay? You have not done anything, but you have only designed an application in your mind. Okay, that is TRL 2. TRL 3 is analytical and experimental proof of concept. So either you can do some simulation in the computer or do some little bit of experiment in your lab and then say that yes, I will be able to do it. Because only you are not in the book, you have also done some experiments. Okay, little bit of experiment and get convinced that I can do it. So if you have done up to the experiment level or analytical level, then you are at TRL 3. Then you go to component or breadboard validation. You know, all of you know breadboard. So in the breadboard, you can put some components and make something. Though breadboard is given for the electronics purpose, similarly mechanical also, people also can have some components and combine, and they can also make something. The breadboard concept is you need not make it firm joining. You can also disassemble it again and you can modify it. Okay, like in childhood you must have used the blocks to make some constructions of houses or different type of shapes. Blocks you might have used. Okay, similarly these are some components, universal components. You can combine like your NAND gates and NOR gates. So you have only blocks. You can combine and make some circuits. Okay. So this is TRL 4, okay, but it is validated in the laboratory environment. Suppose you are making something for the agricultural field, but you have tested in your lab, not gone to the agricultural field, okay? But components breadboard validation in the relevant field, same component, but you have taken to the agricultural field, farmland and tested there. Then you have gone up to TRL 5. You have not gone there, only you are thinking that it may work there, then you are in TRL 4. So TRL 5, then TRL 6 is system, subsystem and prototype demo in lab. So I have made bold, same lines I have drawn from the NASA side. You can see the lowest one, the principle, and in the 6th and 7th, you have prototypes, system, subsystem and prototype demo in the lab. If you really make a prototype and make the demo, then that is TRL 6. In the lab, if you do the demo, TRL 6. If you do in the relevant field means wherever it is going to be applied. If it has to be applied in a kitchen, you have to take it to the kitchen. If it has to be applied in your hostel room, then it has to be taken to the hostel room. If it is to be applied in a railway station, that has to be taken to the railway station and tested, okay? So that is called TRL 7, okay? Then, so in this particular talk, we are not going beyond that. We are starting from TRL 1, that is principle, going up to 6 or 7, okay? Like our educational institutes or engineering colleges, they are not supposed to go to the highest level like actual system, implement in the field, and then take feedback from them like what we have done. Our technologies are now connected in JSW, our systems. So they are giving feedback. So we are in TRL 9. But we had gone all these levels. Okay, we had done a simple image processing using a web camera, then gone for industrial camera, done in a simulated environment. Something is falling at a very high speed. How to simulate that something is falling at a very high speed and capture the image? So what we did, in a particular fan, we made a plate, made some circles, and fan we rotated at very high speed. Okay? Then taken the image. If the image is properly coming, that means our system can also capture high speed falling items. Okay? So that is how I am simulating, but I have not connected in the real environment. Then when we went to the real environment, we found there are a lot of challenges. Okay, there are a lot of dust, there are a lot of background issues and all that. Then we have to modify. So every stage you have to work hard and do something. Okay. So last one is the actual feedback received from the industry, actual product to be developed, and the tests. Okay, TRL 8, 9. But we expect at least any product you go up to TRL 6. Okay. So this is some questions to you, that why I can make prototypes. You ask yourself, okay, which will give you confidence that yes, I can make it. Why I am not making? There are also some questions. I am just reading one by one. You will yourself think that yes, it may be true. It may not be true for everybody. Okay. So first is why I can make prototype. I am educated enough, done hands-on labs during my study. Like in our college days, we have done something, like he has done something in the school days for model competitions. Here also in engineering, you are doing some practicals. Okay, instruments are there. So I have studied some concepts. I am not a very layman that I have not seen a multimeter or something like that. I am not a small kid like a school student. So I can make. I know many scientific and technological principles which can be converted to an innovative product. Innovative product. So what is innovative? Innovative means it should have an application. It should have a commercial value. Okay, and it should be somehow new, something new. Okay, new idea, new way of doing things, but not that it is just a new things, but it has to have a commercial value. It should have a market entry. Okay, you do whatever you do, but if some customers are there, that is called an innovative solution. Okay. Then I have basic infrastructure to develop prototype, because you are in an engineering college, you have a lot of infrastructure, like you have workshops, you have laboratories, you can make something. I am open for collaboration. You have mechanical engineering, civil engineering, so many engineering are there. You are open. Now your friends, you talk to your mechanical engineer, you do mechanical part, I will add electronics part, computer science fellow can add some programming, then you can make a system. I understand the user requirement. Somebody came to us, said that I want something like this. Okay, then you can understand their concept and relate that, yes, these are the things, if I connect, then I can make a solution for him. Okay, suppose in houses, there is a possibility of thief entering into the house when nobody is there inside the house. Okay, now somebody will say that, sir, I want some security system. Somebody will say, you put cameras. What will happen to the camera? Thieves will come with mask, face, and he will go away. Okay, nothing will happen. So you have to catch him when he is entering, or you have to alarm something so that he will not take anything and go away. Okay, or you do something to your house that he will think, the thief will think that as somebody is there, they might have put a lock outside. Maybe the lights are glowing, the sounds are coming, so somebody must be there inside. So I will not dare to enter inside. So you can think, there are a lot of possibilities. So you can have random lighting. Sometimes this room light will glow, after some time other light will glow in night time. Okay, so that the thief will not mark that this house is always locked, nobody is there, they might have gone outside. Okay, they will not think, or they will not dare to get into your room. So like this, any requirement is coming, you should make some idea. Why I am not making? Do not know how to make it. So you can easily say that I have never made anything, so I do not know how to make. And also not having any interest. Have not got appreciation on my previous prototype. He might say, I had made some generator, but no prize given to me, so what is the point in making such things? Okay. Or lack of funding, I need some lot of money, I don't have money. Or do not know how to use the prototype. Suppose I make something but nobody is taking, so there is no point in making it again. So do not get time. It may not be required in my field of work. I can simulate something in a computer. It is very easy to simulate and give the result and get good marks instead of breaking my hands and working hard to buy components, assemble components. Okay, so all these are excuses, but that is not true. So I am showing some key principles of some of the items we use in household. Okay, but this is not limited. Any item you tell, at least with my knowledge, I will be able to make out what could be there inside, whether it is a projector or whether it is a AC, whether it is a TV, what could be inside. Okay, using our electronics knowledge, or any item. Suppose it is wireless, so what should be there so that my voice is getting communicated to that? What could be the frequency? Okay. So all these, based on our engineering knowledge, our education, our subject knowledge, we should be able to make out. So one of them, the first one is a house cleaning robot. Okay, house cleaning robot. This robot will go move around this house. Okay, and if there is any obstacle, it will come back. Okay, it will not get trapped there. Come back and clean and soak all the dust and collect it in somewhere. And that can also go back and dislodge all the collected dust to a particular dustbin and again go to the charging station and stay there. So it is a requirement. And it was of lot of use during COVID time. Many houses, those who are capable of paying for maid servants, they were completely dependent on maid servant for cleaning houses. Okay. Now, when COVID time, nobody came to house. So everybody started purchasing such type of robots. And they were hotcakes and they were purchased, including I also purchased one of them. And I have a video to show how it is sucking the dust. So next one is a utensil cleaning, dishwasher. Okay, dishwasher, you know, particularly they also be dependent on the maid servants for cleaning the utensils. Okay, but this is a machine where you put all the utensils and start, it will clean everything. So what could be the principle? Can you say what could be the principle in a robot which can clean the house? Sensor. Only sensor will not do. So when it will go to a particular area where dust are there, okay, then it will take all the dust inside. So there should be a vacuum system to suck. Low pressure it should be created to suck the dust. Okay, but sometimes dusts are also very sticky to the surface. Okay, so there should be some kind of mop or some kind of brush to collect the dust nearby to the center area where the vacuum opening is there. Okay, then only it can suck and keep it in a filter. Okay, so when something is sucking, that means the air passage is there. Air has to come from outside to inside. Then same air will also go out. Yes or no? Or that will air also will stay. So when air is coming and going out, then that will also throw all the dust it has collected. So you have to again connect, put some filters. Okay, there. So that dust will come, dust will stay, then only the air will go. Okay. So like this one can make. So what is there inside a vacuum pump? It is nothing but a motor. Something is rotating. So when it is rotating like a pump, water is coming. The air can also come by a pump when there is a flap rotating. So it will push the air from one side to other side. So any pump, you can connect a propeller, some kind of fan arrangement, and you can make a vacuum pump also. Using DC motor, many people have made vacuum pumps. Okay. Similarly, dishwasher, how to clean the, and then obstacle avoidance, like he said, sensors. So obstacle is there, then it should sense that there is something, it will come back. After coming back, what it will do? It will change the direction. So first it will go, see that some obstacle is there. Okay, so checking the obstacle, there are many sensors, non-contact sensor, contact sensors. Non-contact means ray is going and coming back. If there is an obstacle, something will come back, like IR sensors are there, or ultrasonic sensors are there. Okay, so that can easily detect and get the signal. So as soon as the robot gets the signal, then it will rotate. It will not go forward. It will rotate towards right. So how can you make a motor? How can you make a robot rotating right? Who can say? A robot is there, having wheels this side and this side. So what you will do to the two motors so that motor will rotate to right? Who said? Very good. He said stop one motor. Which motor to be stopped? To rotate this side, right side motor to be stopped. So this is not rotating, but this is rotating. So what will happen? Move this side. So principle is known, stop one motor. So you give a control signal. As soon as you detect, stop this motor so that it will. So can you not make a prototype of this? But we are not making, we are all buying, and all are made in China or Taiwan or some other countries. We know all principles, we can make, but we don't make. Okay. So I have a video for this too. Then we'll discuss about the dishwasher. C folder, desktop. So there are some dots there. So you can see here some dots are there. Is it visible? So is it visible? So it is cleaning. It is taking all the dust. So I am rotating through remote. So they have given a remote to rotate. Otherwise you can make it intelligent. So this is cleaned. Okay. That means there are two fans moving like this. One is moving this side, other one is moving this side. They are having small brushes. So I have a slow motion video to show that. You can see how the fans are rotating. Okay. This is a slow motion video. Some mobiles having feature of slow motion. So you can see. So one brush is rotating clockwise, other is rotating anti-clockwise. That is how they are collecting to the center. And in the center there is another brush and a sucking pump, which is actually pulling it and keeping in a storage bin. Okay. So next we are going to show a dishwasher, which is like this. Okay. So you can keep lot of utensils inside. And what could be the principle? Who can tell? So any kind of items you can keep inside, and that can clean. Pressure cooker, all these Indian utensils also you can keep. And there is some drain. Okay, and there is a fan type of thing which is not visible in the next video also. You can see this is a fan type of thing. Okay, that is having lot of small holes. Okay, and there is a pump which at a very high pressure it is spraying the water in all directions. Okay, if you spray at a very high speed, any kind of dirty utensils, they can be cleaned. Yes or no? You need not wash it by hand by scrubbing it. Okay. Yes or no? You put very high pressure jet. Similarly, here also there are a lot of small holes with randomly going high pressure water getting sprayed. Okay, from side, from this side, from that side, every side it is going. That is why it is getting cleaned. So there are some cycles. First it will pre-clean, then there will be some soft spray, there will be hot water spray, there is also a heating element to heat the water. You can set how much timing. Okay, all these are timer is set. So all these basic principles they have added and made a dishwasher system, and now we are buying at 35,000 rupees or 25,000 rupees and using it. Okay, but all are of same principle. If you check Samsung, IFV, or I think Faber or LG, any kind of washing dishwasher or washing machine, all are of same principle. All are same principle. Okay, but we have not yet made any product because the prototype stage we have missed. When the foreign countries people, they made prototypes, products, and started selling. Now we are thinking of making prototypes. Okay, so they will be definitely cheaper. Now we have to think making prototypes where the products are not available at all, which is a new and innovative product. Like we made a product, named it as eye on pellet. Okay, there is a iron industry. They were producing lot of spherical balls kind of thing from iron or fines, which are finally used for steel making. So the ball size, they are called pellet. The size monitoring was done by human. A person will move from one place to other place to check whether the size is increased or decreased. Okay, but there was no instrument. We thought if a person is watching by eye and taking a decision by brain, what is the replacement for that in electronics? Watching by eye, which can watch? जोर से बोलो सब. Right thing you are telling, why telling less voice, low voice? Okay, so camera. Okay, so camera, everybody watch, see, having camera. So we can make it to watch by a camera. Then what we are understanding, whether it is big or small, we can write a small code from the camera image. We can say it is a big or small. That is called image processing. Okay, that will also be not very difficult. You can also read from the first year itself. That is not difficult. Okay, so camera image processing system we developed, and you know the cost of the equipment we have sold, 1 crore. Okay, one instrument 1 crore rupees. Because they are big industries, they can pay for 1 crore rupees. And it's a very simple principle. Camera, computer, some codes. Okay, but there is no substitute. Now the third item you can make. I am giving you the charge. You make, I will buy. Okay, this is a roti maker for home. The elderly people, they are not able to make rotis, chapati. No, roti is a good food for everybody. So for making roti, how many stages are there? को ओडिया रे आग कौन कर अटा चकटिया पड़ो नहीं कि गुला करा पड़ो बेलिया पड़ो सेकवा पड़ो तावे पुणी आउ थे 4-5टा जाक स्टेप को गोटे इन्स्ट्रुमेंट भितर रखा पड़ो किए कर कह मुझे बतेबी आईडिया देवी किए कर कह हाथ टक झील मैंने करवा कथा नहीं कौन हम कम कमिज सब पिला पुओ पिला भी करवा कथा कहीं आजिकल ना कि खाया पड़ो नहीं कि से जो रोटी अटा जो दौरान एत भल ना कारण देख गोटे अटाटा को जब गोलेबार अच्छी से गोटे मेसीन रे कौन कर गोटे पटे अटा टिके जीव है जी गोटे गुलापाई दरकार जी अटा से अटा नवा तापर तादर टिके पानी जी दरकार क्वांटिटेटिवली आम देपर गोटे भाल्व लगेदेले जी पानी दरकार से जापर ठीक अच्छे आउ टे तेल भी पकाउछन्ति कारण काले लाखीज बोलिकी है कहीं हाथ में सीना गोटे टाइप ऑयली अच्छी बोली लाखुनी हाथ में कि स्टील रे लगुनि तो काले लगे टिके तेल भी पकाउछन्ति क्वांटिटेटिवली तुम देखिकी तापर खाली गोटे काठी खाली गोटे मोटर लगे खाली एमती खाली गोल गोल कर देखिए केत समय पर गोटे गोला हो ना नहीं क्वांटिटेटिव टिके टिके पानी पकड़ पड़े एका पानी पकईदे कादुआ हो नहीं टिके टिके गोला पड़े आम चेष्टा करूँ से एका बेले जब पानी जमी आम हाथ में चकुटी सेमती प्रिंसिपल कले हेनी एका पानी पकईदे हेनी से एका बेले अलग तार कंपोजिशन अलग हो अल्प टिके पानी पकेब अटारे एमती बुलेब कौन हम कह इमेजिन कर कौन हम टिके 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 गोटा 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 हो नहीं कि माने किछि किछि अठा हम बाकी धड़ा धड़ा अठा थी आउ टिके पानी पकईदेव आउ टे गुलेब आउ से जो गुलाटा आउ टिके टिके बड़ हो जो छोट छोट पीस थी से आउ टिके टिके बड़ हो आउ टिके पानी पकड़ आउ टे गुलेदेव देखिए से साइजटा बढ़ी 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 सब जाक अठा को अठा मिसिक गोटे गुला हो एतिकी कर कह एतिकी प्रोटोटाइप मोटर तो मिलूँ बहुत मोटर डीसी मोटर आमाजन में किण 100 टंका 200 टंकार तुमको मोटर मिल पावर सप्लाई तो अच्छी गोटे गुला बनइबार अच्छे गुलाटा जब परफेक्ट बनीगला तापर कौन हम ना से गुलाटा को आउ गोटे स्क्रापर टाइप थी से ठेलीदेव आउ गोटे जगह है ठेला बेले दुईटा डिस्क थी एमती से मेसीनटा भी मिलूँ गोटे रुटी मेकर मिलूँ चिपीदे से फुली जाऊँ सहीटा को किणी आनिमा है सेटा पड़ुची बोधे 1000-1500 टंका पड़ुची सेटा किणकी कहीं तादे से तलटा अच्छी प्लस ता भर गोटे कॉइल अच्छी हिटिंग कॉइल ताको भंगा हम है तार ऊपर तल दुटा नब तादे गोटे मोटराइज्ड सिस्टम मिलूँ मार्केट रे दैट इज कॉल्ड लिनियर एक्चुएटर गोटे मोटरटा बुलला माने से तल ऊपर हम मोटर केमती बुलूँ मोटरटा सब सर्कुलर बुलूँ एमती गोटे मोटर अच्छी जोटा कि बुलिला माने गोटे साफ्टा आगू आसो कर तो सेमती मोटर मिलूँ मार्केट रे सो यू कैन बाय दैट मे बी 2000 रुपीज कॉस्ट और समथिंग लाइक दैट तो सहीटा को लगेदेव कौन डिस्क ऊपर टे वेल्डिंग फोल्डिंग करके लगेदेल मोटर ऑन है मैंने से तौक जीव मोटर को उल्टा से बिकज ये डीसी मोटर द प्रिंसिपल ऑफ डीसी मोटर इज इफ यू गिव पॉजिटिव नेगेटिव इन दिस डायरेक्शन इट विल गो रोटेट क्लॉकवाइज अपोजिट जो देदेव एंटी क्लॉकवाइज जाकि ऊपर पड़ेगा है सो यू कैन कंट्रोल योर डीसी मोटर डाउनवर्ड और अपवर्ड है ताल कौन हम तुम चाहिए प्रेस कर तौक छाड़ प्रेस हो गला टिके समय तापर हिटिंग देदेव से हीटर अच्छी पावरटा सब कंट्रोल करने कौन अच्छी गोटे पावर केतल देव मोटर केतल जो कंट्रोल करने इलेक्ट्रोनिक सर्किट अच्छी है गोटे माइक्रो कंट्रोलर ऑर्डिनो माइक्रो कंट्रोलर लगे ऑर्डिनो के जन कर कई करना जन जन कर एटलिस्ट शिखिज ये भितर स्कूल पिला माने कले है तुम निजे निजे शिख गोटा कहीं शिखेबे कारण स्कोर्स ना बट दैट इज वेरी गुड आइटम शिखिगले कौन हम ना गोटे रिले लगेदेव ताक टक कला माने से चलो रिले ऑफ कला माने ऊपर को चलना नहीं तापर हिटर ऑन कर आउ गोटे रिले लगे हिटर को सिग्नाल गला माने हिटर ऑन है गरम हो गला माने कौन सी आउ लाखिबन ता चापीदे लाखी जावा कथा ना किंतु गरम करदे लाखिबन जब टे आगु गरम भी कर प्री हिट कर उठीगला तापर थरे दी थर एपट सेपट कर लगेदेला से बाहरी गला दैट मस्ट बी ए लूजर वन टे लूज थी लगी न तो ताकू आ गोटे समथिंग मेकानिकल डिवाइस लगे साइड ठेलीदेव बाहर को पलि आस प्रिंटर रू गोटे पेपर बाहरी आसला से गोटे रुटी बाहर के आसो किए कर इजी ना नहीं सो ऑल द प्रिंसिपल्स आई हैव टोल्ड नाउ यू हैव टू मेक इट हम ना नहीं केते टंका 5,000 टंका खर्च हम दिनेश सर देवे स्पॉन्सर करेंगे कैसे okay so there are other items also because time is short next you can know the principles next okay so this I told you to make okay so there are some already available market that is called Rotimatic but the cost is about 1 lakh rupees okay but I think we can make it in 10,000 rupees everything next this is another thing for diabetes checking so what are the principle behind it you have to know okay next so if basic principle is proved so possible prototype can be designed And then product can be made with optimized design. Next. So prototype is important because it can give you a feasibility study. There is always scope for improvement. Investors get confidence. So if you make a prototype, a roti maker, so that actually roti is coming, good quality roti is coming, many people will come. They will say, you give us the technology, or I want to establish, a lot of money are there with people. So they will invest, okay, and a factory can be made. Project with prototype demonstration has more value. Rough idea about its pros and cons can be known. एक बार तुम लोग बना दोगे एक प्रोटोटाइप, उसका कहाँ पे काम करता है, कहाँ पे नहीं करता है, that you can make out, okay, pros and cons. मनकर सेतबेले कहवा जे अधिक पानी पड़ले होउनी कि कम पानी पड़ले होउनी, सेगुड़ा सब तुम जानीदेव जो गोटे प्रोटोटाइप बनइब, खाली आइडिया करदेले हेनी, सब आइडिया कर देथिबो, लास्ट को काम करबनी. डिफेन्स जाई गुली फुटेला बेलू फुटुनी आउ कौन कर नहीं, तेणु सेमती हेनी. तेणु प्रोटोटाइपटा बहुत थर ट्रायल कले जाकि जानिबो जे एटा काम करछि कि नाही. नेक्स्ट. So reverse engineering also you can do. You can buy something and dismantle it and see what is the principle. Next. Prototype leading to commercial product. So India lacks very significantly in commercial product design. Habit of prototype design may lead to novel product design. Next. So there are a lot of tools like graphics, software, 3D printing. For rapid prototyping controller, you need high level language like you learn C programming. In all branches C programming is taught. Why? Because for every branch you require a programming skill. It is not like only the software people require. In embedded system we require C programming. Without coding we cannot do any. So when the valve is to be open, when the motor is to be on, when the heater is to be on, I have to write a program for that. Okay, so microcontroller to be programmed using C programming. So the C programming you have to learn very nicely, okay, so that you will be able to make a lot of products. And you have got Arduino, Raspberry Pi there for easy coding, okay, and make a microcontroller system. Then workshop you have to cut something and make mechanical things. Next. So this is the conclusion. So prototype development is a passion. I cannot tell you, convince you to tell, say that tomorrow you will do. It should be a passion, zeal. So when I joined my institute, I was an electronics background, okay? But the institute name is Institute of Minerals and Materials Technology. So what is my role there? What mineral, I do not know what is mineral. What is material also, I have no scope there, okay? But since I am a good electronics engineering aptitude, I have a passion of making prototypes. I have made several systems. So they said there is a pipeline inside the coating is getting corroded in the mineral industry. Can you do a robot which will go inside? I have made a robot using same DC motor, springs, lot of controllers. So the motor could able to move. I put a camera and it could able to see inside. Okay. They said there is a pipeline and when the material is going, sometimes it is getting settled. Okay. When that is getting settled, then if more amount of material getting settled, it will lead to choking. Okay. Then can you detect it from outside? I said yes, there is a impedance tomography technology, I can do it. Then I made a prototype, taken a pipe, put our instruments, electronics instrument, then put water and some material and saw that settling can be detectable. Okay. There is a big mill which is running and the material is inside. Okay, they said from outside, can you know what is the percentage of material inside? Because there's a metallic box, metallic drum-like structure, material is going. If it is half full or 10% filled or 20% filled, can you know from outside? I said yes. How I can know? Because the material is inside, its vibration will be different. If it is half filled, suppose a drum is there, bucket is there or a drum is there, having less water, so you strike, you give less different sound. If it is more, water is more, it will give different sound. So like this, if a mill is there, from the vibration of the mill, I will be able to know what is the percentage of material inside, what is the fill level. Okay, like this, any principle known to me, I should be able to make it. So that is a passion. Why I said passion? Like drawing is a passion. Many people do drawing, art. Okay, some people do singing. Some people do a lot of other things as hobby. Similarly, for engineering student, it should be a passion. And if you do develop prototypes, this will be a hot cake. You will be hot cake in the industry. Okay, many people, many industries will. You need not go for job. Okay, so you will be consultant to many industries. Okay, so collaborate with multidisciplinary branches for prototype. Novel idea is required. Unconventional implementation you have to do. You have to demonstrate. Easy for patenting. So about patenting, I am not telling anything because of shortage of time. Some other time I will tell. So easy to go to the next TRL level. If you are at a certain TRL level, you can move it upward. And then student project and hackathons will be there in a lot of colleges. So we want the Parala Maharaja people to be winner of those hackathons. Yes or no? Yes, because you can do it. You are a small campus, a lot of people are staying inside. So together you can make, and if you have any doubt, any idea you have, suppose you only have idea, you do not know how to make, you come to us through your HOD. So I will give you idea how to make it, okay? Then make it to a level so that it can be demonstrated to outside, okay? Any problem you bring, we can give a solution, okay? So thank you very much for your patient listening. So any question if you have time, otherwise we can end here. Any question? No question, I think. Or any idea you want to make it realizable through prototyping, but you do not know how to go ahead? Okay, next. So next, there will be my email ID. If you have any idea you want to realize it, you can write to me. Okay, and we can do something for you. Okay, thank you.
Thank you, sir, for guiding us and letting our people, our students have the idea about electronics. And now I would like to call our HOD Dinesh sir to present the memento to sir. Now, the last but not the least, I would like to call Dr. Dinesh Kumar Das sir, our HOD, to address address the crowd and present the vote of thanks. Please, sir.
Really, it is an energetic session, and we have got lot of knowledge and experience from our Dr. D.P. Das. I extend my heartiest gratitude to him for sharing his valuable time and sharing his knowledge. And it is high time that he illuminates us, okay, that the students should focus on hands-on training during the practicals and focus for small prototypes. Particularly, I will say that if someone at least comes to do some prototype like roti maker or wash disher, okay, so it will be really useful in our day-to-day life, and you can defend yourself, and we can go for real Atmanirbhar. And I must thank to our principal sir for supporting such program, and also I extend my thanks to our Dr. Abhinandan Swai and other faculty members and ETS members for their constant support for organizing such effective and fruitful programs. And I appreciate Dr. Dipidas sir, and also I request that really he is in association with us since long time in many academic matters, and definitely he will extend his support to the students who really have the passion to make a prototype on their own, and it would be a nice collaboration with the academic industry and this IMT. Thank you so much.
Hello. Everyone are requested to stay here only.
किन्ना चिर तेनू दिल च लुका के रखिया किते वख ना हो जाने मैं तो तू तेनू साह दी लड़ी च मैं पिरो के रखिया किते साह तो ना हो जे मैं तो दूर किन्ना चिर तेनू दिल च लुका के रखिया किते वख ना हो जाने मैं तो तू तेनू साह दी लड़ी च मैं पिरो के रखिया किते साह तो ना हो जे मैं तो दूर मैं भी संगदा तू भी संग दे कि वे बुला तो कहावा जो मैं मंगदा तू भी मंग दे जिंद ना तेरे लावा किन्ना चिर तेनू दिल च लुका के रखिया किन्ना चिर तेनू दिल च लुका के रखिया
बेकरारी ना थी क्योंकि इस दिल की तैयारी ना थी पहले लम्हे में बेकरारी ना थी क्योंकि इस दिल की तैयारी ना थी फिर जो देखा तुझे तो लगा ये मुझे जाहिर कर दूं मैं इस हार को, चाहे हो जरा जरा या बेशुमार हो, है दिल की ये दुआ बस तुझसे प्यार हो, चाहे एक दफा सही या सौ बार हो, है दिल की ये दुआ बस तुझसे प्यार हो, हाँ तुझसे प्यार हो।
अर्पण, अब नहीं हो सकता, तुम बस मूव ऑन कर जाओ।
मैं तेरी आंखों में उदासी कभी देख सकता नहीं, तुझे खुश मैं रखूंगा सोने। मैं तेरे होठों पे खामोशी कभी देख सकता नहीं, सारी बातें मैं सुनूंगा सोने। तेरे दिल से ना कभी खेलूंगा, सारे राज अपने मैं तुझको दे दूंगा। मेरी जान तूने मुझको पागल है किया, मेरा लगदा ना जिया तेरे बगैर। तू मान मेरी जान, मैं तुझे जाने ना दूंगा, मैं तुझको अपनी बाहों में छुपा के रखूंगा। तू मान मेरी जान, मैं तुझे जाने ना दूंगा, मैं तुझको अपनी आंखों में बसा के रखूंगा। तू मान मेरी जान, तू मान मेरी जान, तू मान मेरी जान। मैं साया बन के साथ तेरे रहना 24 घंटे, मैं रहना 24 घंटे। मैं आंखों से चुरा लूं जाना तेरे जो भी गम थे, हाय तेरे जो भी गम थे। मेरी बाहों में आके तू जाना नहीं, ऐसी रब से मैं मांगू दुआ। तेरे दिल से ना कभी खेलूंगा, सारे राज अपने मैं तुझको दे दूंगा। मेरी जान तूने मुझको पागल है किया, मेरा लगदा ना जिया तेरे बगैर। तू मान मेरी जान, मैं तुझे जाने ना दूंगा, मैं तुझको अपनी बाहों में छुपा के रखूंगा। तू मान मेरी जान, मैं तुझे जाने ना दूंगा, मैं तुझको अपनी आंखों में बसा के रखूंगा। तू मान मेरी जान।
अपन तो क्यों कर रहा है ये सब, क्यों और मुश्किल कर रहा है मेरे लिए? तू जा, तू जा बस।
ठीक है।
तू मान मेरी जान, मैं तुझे जाने ना